and welcome to this video. We're going to have a look at HuggingFace's datasets library. We're going to have a look at some of what I think are the most useful datasets, and we're going to look at how we can use the library to build what I think are very good pipelines or data input pipelines for NLP. So let's get started. So the first thing we want to do is actually, install datasets. So we'll go pip install datasets, and that will install the library for you. After this, we'll want to go ahead and import datasets. And then we can start having a look at which datasets are available to us. Now, there's two ways that you can have a look at all of the datasets. The first one is using the HuggingFace Datasets Viewer, which you can find on Google. You just type in Datasets Viewer, and it's just an interactive app which allows you to go through and have a look at the different datasets. Now, I'm not going to, I've already spoken about that a lot before, and it's super easy to use, so we're not going to go through it. Instead, we're just going to have a look at how we can view everything in Python, which is the second option. So first, we can do this. So we just list all of our data sets. Now, I'm going to just write a DS list here. And from this, we will just get, I think it's something like 1,400 data sets now. So it's quite a lot. So if we go len of all DS, or what is all DS, or no, DS list. So yeah, it's 1.4 thousand datasets, which is obviously a lot, and some of these are massive as well. So if we, for example, if we were to look at the Oscar dataset, so in DS list, we could go dataset for dataset in DS list if Oscar is in the dataset. So these are just dataset names. Okay, and we have Oscar. I think PT is, what is PT? I imagine it's probably Portuguese. And then we have all these other ones as well. But these are users uploaded Oscar datasets. This is the actual Oscar dataset that's been set up by HuggingFace, and it's huge. It contains, I think, more than 160 languages, and some of them, for example, English. Obviously, English is one of the biggest ones. That contains 1.2 terabytes of data. So there's a lot of data in there, but that's just unstructured text. What I want to have a look at is the squad datasets. So we're going to be using, we're just going to use the original squad in this video, but you can see that we have a few different ones here. So Italian, Spanish, Korean, you have Thai QA squad here, and then also French as well at the bottom. So you have plenty of choice. Now, obviously, you kind of need to know what sort of data set you're looking for. I know I'm looking for a squad data set, so I've looked for squad. There are other ones as well, actually. If I change this to lower, we'll see those also pop up. Okay, so we have like this one here, and this one. This one doesn't seem to work, but it's fine. Now, to load one of those data sets, obviously we're going to be using squad. We write dataset equals datasets.load dataset, and then in here we just write our dataset name, so squad. Now, there's two ways to download your data. So if we do this is the default method. We are going to download and cache the whole data set in memory, which for squad is fine. I think squad, it's not a huge data set, so it's not really a problem. But when you think, okay, if we wanted the English Oscar data set, that's massive. That's 1.2 terabytes. So in those cases, you probably don't want to download it all onto your machine. So what you can do instead is you set streaming equal to true. And when streaming is equal to true, you do need to make some changes to your code, which I'll show you. And there are also some things, particularly filtering, which we will cover later on, which we can't do with streaming. But we will just go ahead, and for now we're going to use streaming. We'll switch over to not streaming later on. And this creates like a iteratable dataset object. And it means that whenever we are calling a specific record within that dataset, it is only going to download or store that single record or multiple records in our memory at once. So we're not downloading the dataset, and we're just processing it as we go, which is, I think, very useful. Now, you can see here we have two actual subsets within our data. If we want to select a specific subset, all we have to do is rewrite datasets again. So let me actually copy this. So we copy that, and if we just want a subset, we write split, and in this case it would be train or validation. And if I just execute that, so I'm not going to store that in our dataset variable here because I don't want to use just train. We have this single iterable dataset object, so we're just pulling in this single part of it or single subset. And we can also view, so here we can see we have train and validation. If you want to, I don't know, see it in a more clear way, you can use dictionary syntax. So sorry, dataset keys. You can use dictionary syntax for most of this. So we have train and validation. Now there's also, so at the moment we have our dataset, but we don't really know anything about it. So we have this train subset. And let's say I want to, understand what is in there. So what I can do to start is I write a dataset train, and I can write, for example, the dataset size. So how big is it? All right, dataset size, data set, not data size. Don't know what I was doing there. And we see that we get, so what is that? So 80, about 90 megabytes there. So reasonably big, but it's not anything huge, nothing crazy. And we can also, so we have that. We can also get, if I copy this, we can also get a description. And we see what the dataset is. So squad, I didn't even mention it already, but squad is the Stanford question answering dataset. So you use it for generally for training Q&A models or testing Q&A models. And you can pause and read that if you want to. And then another thing that is pretty important is what are the features that we have inside here. Now we can also just print out one of the samples, but it's useful to know, I think, and this also gives you data types, which is kind of useful. So we have ID, title, context, question, and answers. All of them are strings. Answers is actually, so within answers we have, it says sequence here. We can view it as a dictionary, but we have a text attribute and also an answer start attribute. So that's pretty useful to know, I think. And to view one of our samples, so we have all the features here, but let's say we just want to see what it actually looks like. We can write dataset, and we go train, and when we have streaming set to false, we can write this, but because we have streaming set to true, we can't do this. So instead what we have to do is we we actually just iterate through the data set. So we just go for sample in dataset, and we just want to print a single sample. And then I don't want to print any more, so I'm gonna write break after that. So we just print one of those samples. And then we see, okay, we have the ID, we have title. So each of these samples is being pulled from a different Wikipedia page. In this case, the title is the title of the page. So this one is from the University of Notre Dame Wikipedia page. We have answers. So that further down, we're going to ask a question, and this answers here. So we have the text, which is the actual text answer, and then we have the position, so the character position where the answer starts within the context, which is what you can see here. We have a question here which we're asking, and then the model, the Q&A model, is going to extract the answer from our context there. Okay, so we're not going to be training model in this video or anything like that. We're just experimenting with the Datasets library. We don't need to worry so much about that. So the first thing I want to do is have a look at how we can modify some of the features in our data. So with Squad, when we are training a model, one of the first things we would do is we take our answer start and the text, and we would use that to get the answer end position as well. So let's go ahead and do that. So first I want to just have a look, okay, for sample in the dataset train, I'm just going to print out a few of the answer features. So we have sample, answer, or answers, sorry, and I just want to print that. So print it, and I want to say, okay, I want to enumerate this so I can count how many times we're going through it. So here I'm just viewing the data so we can actually see what we have in there. So I want to say if I is greater than 4, just break, just stop printing answers for us. So, and then we have a few of these. So we have text and we have answer start. We want to add answer end. And the way that we do that is pretty straightforward. We just need to take the answer start and we add the length of our text to that to get the answer end. Nothing complicated there. So what we're going to do here is modify the answers feature, and the best way, or I think at least the most common way of modifying features or adding new features as well, is to use the map method. So we go dataset, so it's going to output a new dataset. So we write dataset train equals dataset train, and we're going to use the map method, and with map we use lambda, so we write lambda x. So in here we're building a lambda function, and what we need to do, so this is one of the things that changes depending on whether you're using streaming or not. So with streaming equals true, in here we need to specify every single feature. So what I mean by that is, let me do it for streaming false initially. So when streaming is false, we would just write answers, and we would write the modification to that feature. So in this case, we are taking the current answers, so it would be X answers, and we would be merging that with a new dictionary item, which is going to be answers end. So answer, is it answer or end answer? Where? Oh, answer start. So answer end is equal to, and here what we have to do is we go X answers. So this is a little bit messy, I know, but it's just how it is. So we're within answers, and we want to take the answer start position. So answer start. And we want to add, let me start a new line here. And we want to add the length of answers text. Okay, so all we're doing now is we're taking answer start and we're adding answer text, or the length of answer text, to that to get our answer end. Now, this is all we would have to write if we were using streaming equals false, but we're not. With streaming equals true, we need to add every other feature in there as well. I'm not sure why it is why this is the case, but it is. So we need to just add those in as well. So all they are is a direct mapping from the old version to the new data set. So we don't need to really do anything there. We just need to add ID. We want to map that to ID and do that for the other features as well. So we also have context, which is X context. We have answer we've already done, of course, question, which is going to be X question. So we have ID, context, question, answers. Is there anything else I'm missing? ID, oh, title, of course, title, just title. Yeah. So also add title in there as well. Okay, and with that, we should be ready to go. So let's map that. And what we'll find is when we're using streaming equals true, the actual process is, or the transformation that we just built is lazily loaded. So we haven't actually just done anything there. All we've said is we've passed this instruction to transform the data set in this way, but it hasn't actually transformed anything yet. It only performs this transformation when we call the data set. So if we did this again, this would call the data set and it would force the code to run this instruction or this transformation. So let's run that. And you see we actually do get an error here. And why is that? So let me come down. We have, so what am I doing? And start plus the length of answers. What's wrong with that? Okay, so if we look up here, we have these items here that are within a list. So we actually need to access that first item. But that's good because we saw that when we first execute this code, nothing happened, and it only actually came across that error when we called a dataset, because that's when this transformation is actually performed. And now what we have to do is, because we've already added this instruction to our dataset transformation or building process, we actually need to reinitialize our dataset. So we will come back up here. So where are you? Here. So not that one, this one. So we need to load that again to reinitialize all of the instructions that we've added in there. And then we can go ahead, rerun this. And now it should work, hopefully. Let's see. There we go. So now if we have a look at this, and this is something I probably should have done, but I completely forgot to. So I should have added this as maybe a list rather than just the number, but it's fine because if you come across and you need to do this, you may want to add that in, but we're not doing anything other than playing around with the datasets library, so it's not really a problem. But you can see that we have added answers end into there now, which is what we wanted to do. And also importantly is let me copy this, bring it down here, we'll notice that we do still have all of our data sets. So if I go here, I don't really need to remove that, it's fine. I'll just break straight away, it's fine. so sample, sorry, here. So see the whole thing. And we see that we still have the ID, we have the text, we have the context, we have everything in there. Now, I'm just going to show you, why this breaks, or why what happens if I remove these. Okay, so let me rerun that, and this as well. So yeah, so this should look the same. Do we have, yeah, that's fine. But then if I run this, so before this had all the features, but now we only have the single feature that we specified in this function, so the answers. So that's why you need to, when shuffle is set to true, that's why you need to add every single feature in there. Otherwise, it's just going to remove them when you perform the map operation. But that's only the case when shuffle is actually set to true. Oh, shuffle? Why am I saying shuffle? Streaming is set to true. So let me bring this down here. And let me also copy our initial loading code. So here, because we're going to need to reload our data set now anyway, because we just removed all the features from it. Okay, and what I'm going to do now is just set streaming equal to false. And I'm going to run this same code where we still don't have our IDs or anything like that in there. And we'll see what happens. As well, we'll also notice we'll get a loading bar here, and it's going to take a little bit of time to process this. Although actually with this, it's probably going to be super fast. So probably ignore that. But it will, you see, okay, it's taking a little bit of time. So now it's going through the whole data set. We haven't called the data set, but we have used this map function. When streaming is set to false, the data set isn't lazily loaded, and so the map operation is performed as soon as you call it. So it's a slightly different behavior. And the other behavior which is different is the fact that we've only needed to specify the answers feature here. So when we have streaming set to false, we don't need to include every feature within the map operation. We only need to include the feature that we are modifying or creating, which, it's weird. I don't know why there's that behavior difference when streaming is true or false, but it is there. So if I now take this again, come down here and run that, we see now that we have all of our features again, right? So before, when streaming was true, if I ran this code, it would have only included our answers. The ID, title, context, question, they all would have been removed. But now, with streaming equal to false, they're still there. So so it's a weird feature or a weird behavior, but it's how it is, and we obviously just need to deal with it. Now, the next thing I want to show you is how we can also add batching to our mapping process. So typically with pretty much every, or any, as far as I can think of, any NLP task, we're going to want to tokenize our text. So we're going to go ahead and do that for Q&A. So we would import transformers, or from transformers, import a BERT tokenizer, let's say. And I would initialize that. So this is what we typically do. We do tokenizer equals BERT tokenizer from pre-trained. And let's say BERT base uncased. Okay, I'll initialize that. And then what I want to do is I'm going to tokenize my context, or question and context, in the format that Squad would usually expect when you're doing Q&A or building a Q&A model. And I want to do that using the map function. So you can do this in both streaming and non-streaming, by the way. So we just write dataset equals train. So same as before, dataset equals train, or dataset train map, we are using a lambda function, so lambda x. And in here, we just want to say tokenizer. So I'm not doing the, usually when you write this, you would include a dictionary here, but the tokenizer, the output from the tokenizer is already in dictionary format, so I don't need to do it in this case. But basically what we have here is still a dictionary. And what I want to do is, so with Q&A in your tokenizer, you would pass two text inputs. You pass your question, and you'd also then pass your context. And as usual, we set our max length. So for usually 512, I would set padding equal to the max length, and also do truncation as well. Okay, so very typical tokenization process. There's nothing different going on here. This is what we normally do when we tokenize our text going into a transform model. And then we want to say, okay, batched equals true. So this allows us to do everything or perform this operation in batches. And then we can also specify our batch size. So batch size equals, let's say 32. So now when we run this, where has it gone? It's here. Now when we run this, the map function here is going to tokenize our question and context in batches of 32. So let's go ahead and do that. Okay, and then you can see that processing there. So I mean that's all we really need to do with that. So I think that's probably it for the map method, and I'll fast forward and we'll continue with, I think, a few of the methods that I think are quite useful as well. Okay, so that's just finishing up now, so we can go ahead and have a look at what we've actually produced. So come to here and say dataset train. So what do we have? Now we have answers like we did before, but now we also have attention mask. We have input IDs, and we also have token type IDs, which are the three tensors that we usually output from the tokenizer when we do that. So we now have those in there as well. We can also have a look. Another thing as well, we can now, rather than looping through our data set, because we're not using streaming equals true, we're using streaming equals false, we can now do this. And we can see, okay, we have attention mask, and it's not going to show me everything because it's quite large. So I'll just delete that, but you can see that we have the attention mask in there. So what I might want to do is, say I want to be quite pedantic, and I don't like the fact that there is the, if I remove that we have one feature called title. Maybe I want to say, okay, it should be topic because it's the topic of the context and the question. If I want to be really pedantic and modify that, I could say dataset train rename column. And to be honest, you can use it for this, of course, but you're probably not going to. You're probably going to use it more for when you need to rename a column to make sure it aligns to whatever the expected inputs are for a transformer model, for example. So that's where you would use it, but I'm just using this example. So I'm going to rename the column title to topic. And let's print out dataset train again. So down here we have title. In the moment we're going to have topic. Okay, so now we have topic. So just rename the column. Like I said, it can be useful. Not in this case, but generally this is usually useful. Now, what I may want to do as well is remove certain records from this data set. So far we've been printing out here we have this, which is now topic. We have University of Notre Dame. Maybe for whatever reason we don't want to include those. those topics. So we can say, very similar to before, we write dataset train equals dataset train again. But this time I'm going to filter. So we're going to filter out records that we don't want. And again, it's very similar to the syntax we use for the map function, which is the lambda. And in here, we just need to specify the condition for the samples that we do want to include, or we do want to keep. And in this case, we want to say, okay, wherever the topic is not equal to University of Notre Dame. Okay, so we'll run this and we'll have a look at what we produce. So dataset train. So I just want to have a look. We have the number of rows here, which is just over 88,000. And we should get a lower number now. Now, this will also go through. So this, remember, we have shuffle set to shuffle. Why I keep calling it shuffle. We have streaming set to false this time. So it's going to run through the whole data set and perform this filtering operation. Now, whilst we're waiting for that, now I'll just fast forward again to when this finishes in a moment. Okay, so now we have it's finished, and we have, before we had 88,000 rows, now we have 87.3, and we should see. So let me take the data set, train, topic, and I want to see, let's say, the first 5 of those. Okay, and now they're all Beyonce, rather than before, where it was the University of Notre Dame. So we have those, and what we may want to do now is, say, for example, we're performing inference with Q&A with a transform model. We don't really need all of the features that we have here. So we would only need the attention mask, the input IDs, and also the token type IDs. So what we can do now is we can remove some of those columns. So we'll do dataset train, as always, dataset train again. And we want to remove those columns. So remove columns. And we'll just remove, all of them other than the ones that we want. So do answers, context, ID, question, and topic. Okay, and then let's have a look at what we have left. Okay, and then that's it. So we have those final features, and these are the ones that we would input into a transform model for training. Now, I mean, there's nothing else I really want to cover. I think that is pretty much all you need to know on HuggingFace datasets to get started and start building pretty, I think, good input pipelines and using some of the datasets that are available. So we'll leave it there. Thank you very much for watching, and I will see you again in the next one. Bye.